first day, we're going to talk about graphing quadratics. A quadratic is this guy, y equals x squared. This is the most basic form of a quadratic. This is called your parent function. Remember when we talked about absolute value? I told you that the most basic way of writing absolute value was y equals absolute value of x, right? So the most basic way of writing a quadratic is y equals x squared. This is your parent function. Okay. All right, so here's algebraically. Okay, well, you know what? Let's go and graph it. Okay? In order to graph it, we need to make a table of values. When we use the parent function, we can just do 0, 1, 2, 3, negative 1, negative 2, right? Because the table is just uses whatever x numbers I want, right? So we're going to go in our calculators. We're going to go to y equals and put in x squared. Let's see what that looks like. When I hit graph, well, your graph should look like mine. Does it?
Y equals
X squared. Yep. Just a basic parent function. Yeah? All right, so then let's go get our table. Go to second graph. And, you know, mine's looking at -7. Okay, so 0, right? Okay. So I have my x numbers lined up here. Guys, what is my y number or my y value when my x number is 0?
0.
0. Okay, how about for 1?
1.
How about negative 1?
Positive 1.
Oh, how about 2?
4.
4. How about for negative 2?
Wait, positive 4.
Positive 4. Then how about 3?
3, 9.
So then, what do you think negative 3 is going to be?
9.
Positive.
9. Positive 9. Do you guys see a pattern here?
1, 4, 9, 16.
So how go back and forth to this graph? This is what we're looking at. Okay? All right. So let's talk about the domain. Guys, you remember when I told you about the absolute value graph, right? I said that the domain is always what? Anyone remember? Yeah, the domain.
X.
For the absolute value, which looks like a sharp V, I said that the domain is always negative infinity to infinity, right? No matter what transformations, even if it flips, moves left, right, up, down, whatever, stretch, okay? And that's because we have an arrow going to the left, and we have an arrow going to the right. Yes?
Yeah.
All right, so then look at your quadratic graph. Guys, you have an arrow going to the left. Where's that going?
Negative.
Negative infinity. And you have an arrow going to the right. Where's that going? To infinity. So you know what? Your domain always, all real numbers, negative infinity to infinity. You're always going to have an arrow on the left and an arrow on the right. Alright. So now, okay, let's look at the range. Remember, range is looking at the graph from the bottom to the top. So, does this graph go down to negative infinity? No. Where does this graph start?
The origin.
Yeah, but what y number?
0.
0. And it goes up to where?
Infinity.
Good. That's my range. So my range is
0 to infinity.
good. 0 to infinity. Why did I put a bracket on the 0?
Because it's 0.
It's
something. Yeah.
Because it's what?
I know.
closed circle, right? Okay, we have to include that one. Now, is this continuous? Can I draw this graph or trace this graph without picking up my pencil or my finger?
Yes, it's continuous.
Yeah, there are no holes or breaks, right? So this is continuous. Good. Now, we know it's a function because it passes the vertical line test, right? Okay. Right? Remember, the vertical line test, does this line hit the graph at only one spot? Yeah, right? So, one to one, it has to use the horizontal line test. Remember? Is this graph one to one?
No.
No? Why?
It's two times.
Good, because it hits this graph in two spots. Remember, I can only hit it in one spot if it's one to one. So this is no. Guys, is this okay? What is the vertex?
0, 0, where it starts.
Where it changes direction, right? Right there, that's your vertex, right? Okay, so 0, 0. Oh no. This is not locked. Alright. Sorry. Okay. Now let's see if anyone remembers this from absolute value. What is the axis of symmetry? Good. X equals, remember guys, it's in the name. X is. So X equals, and then 0. Your X number from your vertex. Good. Now, we're going to come back to the increasing, decreasing, and constant. Let's talk about the maximum and the minimum value. So, if I go back and I look at this graph, does this have a max or a min?
Max.
Max. Remember, max means like top, right? So, then that one should look like...
Oh, so minimum.
Good. This is what a maximum looks like. This is a minimum because it's like down at the bottom of the function, right? All right. So my minimum value is what? What is the actual point?
0, 0.
0, 0. It's the same as your vertex. Right? Your max or your min is always going to be the same as your vertex. Okay, so let's write that down here then. Same as vertex. Can I have both? Can I have a max and a min?
No.
No. So since this is a min, the max is none. You can't have both. Only have one or the other. Now, let's talk about increasing, decreasing, and constant. Let's do that because we've done a bunch of that. All right. So here's the thing. I'm going to look at my graph. I have an arrow going to the left, so I'm going towards negative infinity. I have an arrow on the right, so I'm going towards positive infinity. Do you agree? Yeah? Okay. So where this graph changes direction, right at the vertex, I'm going to draw a little dotted line. Right? What is the x number that this dotted line goes through? 0. Good. 0. So there are my intervals. Let's see what the graph is doing. What is the graph doing from negative infinity to 0?
Goes down.
Good, goes down, so it's decreasing, right? And what is the graph doing from 0 to infinity?
Goes up from 0.
It goes up. Good. So it's increasing. So you know what? Let's write that in. Increasing from 0 to infinity. Guys, do we ever use brackets with the increasing, decreasing, and constant? Never. Always parentheses. And then decreasing is from where to where?
Negative infinity to 0.
negative infinity to 0, do we have a constant, like anywhere where it's just straight horizontal?
No.
No. And will you ever? No. Intercepts. Y intercept. Okay, with the parent function, it's really easy to see where the graph crosses through or touches the y-axis. Okay? But can we just make a little note here on the calculator? Y-intercept. You find it by doing graph, trace, 0, enter. Okay? That's a note for ourselves, all right? When the problems are not as pretty, we can get the y-intercepts this way. So the zeros, or the x-intercepts, on the calculator, you go to second, trace, 0. All right?
What about left bound, right bound gaps? Just hit enter.
Yeah, no, all of that I'm going to do later.
And this is error bound.
Yeah, because I didn't show you how to put it in the calculator yet. Okay? All right. So, if I go back and look at this graph, where is the y-intercept? Where does this graph cross through or touch the y-axis? 0, 0. See that? Okay. So the parent function is nice because, you know, it likes 0, 0. That's where the graph crosses through the y-axis. Now, where does the graph cross through or touch the x-axis? Or, you know, for the x-intercepts?
0, 0.
0, 0, again, right? And that one, it doesn't go through the x. It looks like it just bounces off of the x, right? That has a special name. When it just bounces off. So this is 0, 0. Okay? When it just bounces off of there, it's called a double root. All right? Now, the end behaviors. Remember we did this with absolute value, right? We talked about it like the arms of the graph. As x approaches negative infinity, guys, if you're standing on the x-axis and you want to go towards negative infinity, which way do you have to go?
Left.
To the left. So this is talking about the left arm. So let me go back and look at the left arm of this graph. Where's it going?
Up.
Up. Up to where?
Infinity.
Good. Up to infinity. Now, then look at the right arm. As x approaches infinity, then now we're talking about the right arm, right? What's the right arm doing? It's going up as well. Are they ever going to do something different? No, right? They both have to be going up or they both have to be going down. Okay? Questions? All right, you guys are doing a really good job. It's very similar to the absolute value function, isn't it? Yeah. Now let's look at vertex form and we're going to talk about transformations. Okay, so this should be a review for you guys as well. I'm going to start from the back here. I like the K. Guys, if I see a number there, plus K, like plus 2 or plus 1, how does that make the graph move? Yeah, okay, thank you. I mean, guys, these rules, it never changes. Okay? It just looks different because we're applying it to a different function. But the rules don't change. So then minus K is
Down K.
down K. Good. Now, inside the parentheses squared with the x, right? This one's a little bit tricky, right? If I have x minus h, so like x minus 3, how does that make the graph move? Take a guess.
To the left.
Okay, that's what you would think,
Or to
right?
the right. Because the opposite.
Good, opposite. You would think it should be left because it's minus 3, but when it's with the x inside a grouping symbol, it's the opposite. Okay? So then this would be right, h. Good. I'm glad you guys guessed. Good. Tell me what you're thinking. Okay? So then x plus h has to move how?
To the left.
To the left. Does that make sense? All right. So then the last guy, A. So A is busy because A has 3 different jobs. If there's a negative in the front, what happens?
Flips.
Good. It flips or it reflects. But how about if there's a number out there that's bigger than 1? Does it stretch it or compress it?
Stretch.
Good for you. You're on a roll. But what if you get a number that's smaller than 1, but it's bigger than 0? So like 1/2. Compress. And just because it's a fraction doesn't mean it's smaller than 1, right? We went over that. If you have 5/4, that's bigger than 1, right? Okay. So don't think it's always a fraction, right? It has to be a number that's smaller than 1, but bigger than 0. Questions? All right. Then let's look at this next part here. It says, describe the transformation of our parent function, quadratic, right? F of x equals x squared. And then write in the new function in vertex form, okay? So what am I saying here? Here's where the graph is right now. That's the vertex. Do you agree? Right? What was the vertex for my parent function? The original, the most basic that we did when we first started the lesson. Go back to it. What was the vertex? Go back to your notes. First page. What was the vertex? 0, 0. So what you're doing is you're comparing it to your parent function, and you're telling me what changed here. So we were at 0, 0, and it was a U shape, right? Did this flip?
Yeah.
No, it's still U shaped, right? How did this graph move from the vertex at 0, 0 to this green one? How did it physically move? No, it didn't flip. That one flipped.
It moves right 5 and up 2.
Okay.
Yeah.
Right 5. So 1, 2, 3, 4, 5. Okay, right 5. And what? Up 2.
Up 2.
Good. Perfect. So transformations, we have right 5, up 2. What is my new vertex here, guys? The green one. What is the actual point?
2, 5.
Not 2, 5.
5, 2.
5, 2. Right? Okay, so my new function, well, I know it's y equals parentheses with the x. And I know it's squared, right? So now we're going to fill in. I don't need to put anything in the front because it's not like it flipped or stretched or compressed, right? What goes inside with the x? Up, down, or left, right?
Minus 5.
So
move right 5.
Yeah.
Okay, right 5, so it has to be minus 5. Okay.
And
How about the up 2? Where do I put the up 2?
plus 2 at the end because it's up a to
There we go. Yeah? Does that make sense?
Yeah.
And I'm not going to give you a graph that looks like that and do a stretch or compress. It'll be very obvious, or I will tell you, okay? But most likely with the stretch and compress, I'll give you the equation. All right? So you guys try the next one, please.
this
Try it out. Write it down on your sheet.
This one.
All right, so remember, your vertex was at 0, 0, and it was pointing up, right?
Yeah.
So now this guy is pointing down. Well, then that tells me that it reflects or it flips, right? And let's see how it moved. It went 1, 2, 3, 4, 5, up 5. 1, 2, 3, right 3. Yeah? Up 5, right 3. Yeah? So my new vertex over here is 3, 5. Yes? Okay. So then my function, so I have y equals, and then I have the x with the square. Since it reflects, what do I need to put in the front?
Negative.
Negative. And it went right 3, so this is going to be minus 3. And up 5,
Plus 5.
so plus 5. Good. Did we all get this?
Yes.
No! Oh no! Okay.
I got this.
Listen, if you need to, do something like this. Like with the X, right under it, put left or right. And over here, put up or down. You know what I mean? Then it kind of helps you to remember left, right, up, down. Yeah? Okay.
You don't put the A in there. You don't put negative A. You just put negative.
You just put negative. Because it's negative 1. Alright, so what we're going to do is we're going to practice graphing a couple of these, okay? Let's look at number 1. Alright, so guys, number 1 is in vertex form, right? We could easily just get the vertex right from the equation.
Yeah.
But I want to make sure you guys know how to find the vertex, even if it's not in vertex form, okay? So I'm going to show you how to do that. It's all in the calculator, okay? So let's talk about the transformation first. All right, guys, every single one of these, I have a negative in the front, I have this, and I have that. Yeah? Tell me in words, how did it move? How did it change?
It flipped.
Okay, it flipped because of the negative. So I'm going to write reflects. But you can write flips if you want, all right?
Vertex.
And then what about that x plus 4?
Move
How
to
did
the
that?
left.
Good. Left 4. Great job. And then
Up 2.
up 2. Super. Now, what else do we know that I could plug in? Because this is always, 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 always. Okay, well, not the vertex yet. What did I say is always the case? It never changes, no matter what transformations it goes through. Yes, what is negative infinity to infinity? What? Which one? Huh?
I mean the infinity. Wait.
The domain. Guys, the domain is always negative infinity to infinity. I'm sorry, maybe I just wasn't clear. Okay. Thank you, Abner. Apologies. All right. Before you even start this, domain is always negative infinity to infinity, okay? Don't anyone get that wrong. I don't know if that makes sense, but do not get that wrong, okay? All right. So now let's talk about getting the vertex and the axis of symmetry. So the vertex you can get straight from the equation because, do you remember? Opposite the number with the x, which is what?
-4.
And then your k number, which is 2. That's your vertex. I'm going to show you how to find that calculator too. Alright guys, let's put this whole entire equation into y equals. Was it plus 2? Yeah, plus 2. So make sure you put this in the calculator. You have a negative in the front, that's not subtract. That's this negative next to your decimal, okay? When you go to graph it, this is what your graph should look like. If it does not look like this, then please let me know. So, pause for a second. If you guys are filling in your table, that's great, but I want to show you something. Look at this graph. Your vertex, I told you, is going to be a max or a min, right? What is this?
Yours max isn't the stop
Max.
sign.
Which one is it?
Max.
Max with
Max. Because it's like at the top of the mountain. This is a max, okay? So this is how you're going to find it in the calculator. We ready? Focus? Okay. Go to second trace. Go to maximum. Just the fourth one down. Alright? So, here's where I am. It says first curve, right? So look at this. Mine says x equals 0. That means when I'm at 0, where's my graph? It's probably like all the way down here somewhere, right? I need to bring that. There's a little blinking bob. I need to get blinking bob up here. So I'm gonna hit the left arrow. There he is. You see him? Get blinking bob. Bring blinking bob up to your maximum. Yours looks different? Oh wait, hold on. What is happening with mine then? Let me see. Maximum? Oh, okay, sorry.
Then the little thing isn't
I must have hit intersection.
It gives like decimals.
What little thing
Okay.
isn't popping up?
Alright, what does your X number say?
Maybe go to the left, like to the left.
Oh, oops.
Alright, so it's okay if we have those decimals there, that's fine. Here's what you're doing, okay? This is really, really weird. I just need you guys to trust me. You want to always move blinking bob to the thing that you want. So I want this, the vertex, so I'm gonna move him there. So what you're doing is, that's your starting point. This is where you're starting, okay? Your calculator saying, go to the left. So hit your left arrow like 3 or 4 times. 1, 2, 3, 4. Hit enter. Now, bring him back. Bring blinking bob back to the starting point. Okay? Don't hit enter. And then your calculator says, go to the right. So now to the right. 1, 2, 3, 4. Then hit enter. It says guess. We don't want to guess. Hit enter again. So I have negative 3.99999, which is negative 4, right? Some of you may have negative 4.00000, which is negative 4, right? Some of you may just have negative 4, comma 2. That's fine. Okay? Did anyone not get this? It's weird. But what you're doing is you're making blinking bob dance is what you're doing. Okay? Start at the point, you go to the left. Okay? You go back to the point, and then you go to the right. Does that make sense? Alright, did anyone not get this? You need me to show you? Alright, so this is how you can find the vertex as well. So this is your maximum, negative 4, 2. Okay? So then, do we have a minimum?
No.
No, you can't have both. What is the axis of symmetry? X equals what? Super. X equals -4. X equals the X number from your vertex. Turn it off. All right, so now let's go and graph this. You always want to go put your vertex in the middle, and then just get 2 points above and 2 points below from your table. So somebody tell me, when my X number equals -3, what's my Y? Huh? 1. So then how about for -5? 1. How about -6?
2.
-2?
Yep.
And then -2? Same thing, -2. Okay, so let me go and graph this. So you can go get more points if you want, or you can just leave it here, it's fine. All right. So I want to talk about the range. And you guys are done graphing. Okay. All right, so let's talk about the range here, guys. I have arrows that are going down. Where are they going?
Negative infinity.
Yeah, negative infinity. So that means I'm starting from negative infinity, and I'm going all the way to where? Where does this graph stop?
At 4, -4.
At -4 here?
Oh, 2. 2.
2. Okay, because remember we're talking about the y numbers. Good. At 2, and 2 is a closed dot. So what notation does that get? Bracket. Good. All right, let's talk about the y-intercept. You know, guys, it looks like this graph crosses through the y-axis, but probably somewhere down here, right? I can't see it, but I know that this graph is heading down. It's going to cross the y-axis somewhere, right? So the easiest thing I would do is, you know what? Go back to the calculator. Go to graph. We wrote this down in the first page, but let's try it out. Graph, trace, 0, enter. What do you get? 0, comma, -14. That's the y-intercept. Isn't that nice? Yeah, your calculator does all the work
But
for
how do
you.
you get to like y?
Okay, so ready? So hit graph. Regular old graph. Okay. Hit trace. 0. Enter. Do you see it?
Yeah.
0, comma, -14. 0, comma, -14. Okay? So now let's talk about the x-intercepts. All right? So guys, this is another really weird one because x-intercepts are where this graph crosses through the x-axis. Yes? If you look at this, it looks like it's right here and right here, right? Do they go through really nice, pretty points? No. These are going to give me decimals, right? Here's what we need to do. We have to use a calculator here if we're just doing this, okay? Now, go to your calculators. We're going to hit graph. Get it nice and clean. Now, we're going to go to second trace. 0. 0 is another word for the x-intercept, right? So 0, hit enter. Now we need blinking Bob again. If you look, mine says x equals 0. It means I'm all the way down here somewhere. Hit to the left, bring him back. There's blinking Bob. I'm going to put blinking Bob on this x-intercept right there, because that's what I want. Yeah? That's what I want. Yes? Okay, so now, calculator says go to the left. So I'm going to hit the left arrow maybe like 3 times. You just don't want to go past the vertex, okay? So left, 1, 2, 3. Hit enter. Now, go back. It's a little dance, right? You have to go back to the starting point. And then it says go to the where? To the right. Right. 1, 2, 3. Yeah? Hit enter. We don't want it to guess. We want to hit enter again. And look, you should have negative 2.5. We'll round it up to 2 decimal places here. Negative 2.59, comma 0. You got an error, is your boundaries. Did we get this?
Yep.
Yeah? Sabrina, are you okay with this? No? Did you get this, Abner?
Yeah.
Abner, can you show Sabrina? Tom, I'll show you, okay? So, x-intercept, we have negative 2.59, comma 0. And let's go find the other one, because we have 2, right? We just found this one. Now we have to find the one on the left. It looks like it's between negative 6 and negative 5, right? All right, so let's do that again. Nice practice for us. Graph, second trace, 0. Now I'm going to move my blinking Bob over to the other one. That's what I want. It's okay if you can't get it right on it. You just want to be somewhere near it, right? Now, we can start his dance. Go to the left. 1, 2, 3. Hit enter. Go back to the starting point. And then it says go to the right. So to the right. 1, 2, 3. Or hit the right arrow. Okay? Hit enter again. Don't want to guess. Enter. And this is what you should have for your 0. Did you get this? If you did not, please let me know. Okay, so you should have negative 5.41, comma 0. Yeah? Negative 5.41, comma 0. Perfect. Okay? So we found both of our zeros. They were decimals. If we solve this, probably have a square root with a with a number and all of that. That's why we get a decimal. Okay? All right, so now we're going to look at increasing and decreasing. Guys, if I have an arrow on the left, where is that going? Arrow to the left? Huh?
Negative infinity.
Yeah, negative infinity. I have an arrow on the right. Where's that going?
Infinity.
Infinity. And we need to draw a dotted line through our vertex, right? What x number does this go through?
4. Negative 4.
Negative 4, which is the same as your axis of symmetry, right? Here are the intervals. Now you just have to tell me which one's increasing and which one's decreasing. What is it doing from negative infinity to negative 4?
Increase.
Is what?
Increase.
Increasing. Good. It's going up from the left to the right. What is it doing from negative 4 to infinity?
Decreasing.
Decreasing. Good. Right? We always look at the graph from the left to the right. So now we can go and fill this in. Increasing from negative infinity to negative 4. And then decreasing. Tom, are you writing this down? Stay with us. You don't need to be on the calculator right now. from -4 to infinity. All right? Now the end behaviors, guys, these are the arms of the graph. As x approaches -infinity, which arm am I talking about? X goes to -infinity. You're on the x-axis and you want to walk towards -infinity. Which way do you have to go?
Yeah.
To the left. So this is looking at the left arm. What is your left arm doing? Huh? Going down. Down to where? Good. -infinity. So if my left arm is going to -infinity, what do you think the right arm is doing? Same thing. And look at the left, look at the right arm. Isn't it going down to -infinity? Yeah. There you go. How was that?
It's alright.
It's a lot, right? But the thing is that, you know, calculator will help you, okay? All right, so the next one is also in vertex form. Look at this one. This guy is in standard form, right? You know what I want to do is I want to look at this guy right here, intercept form. Let's look at number 4, please. So I know I gave you some hints there, how to graph an intercept form, find the x-intercepts, find the vertex, draw a parabola. You know what? Put it in the calculator, okay? Let's do this. Let's put this into the calculator and we can go and get the vertex, max, min, that stuff, okay? 2. So y equals right? Just put it in exactly the way you see it. It doesn't matter which form you put it into the calculator, it's all going to compute it the same way for you. Let's graph it. Let's see what this graph looks like. Whoa. Yeah? How many of you guys, the vertex, does it get covered up a little bit down at the bottom? But will it when you go to like do left bound, right bound, all that stuff? If you want to move it down just a little bit, okay, here's what you do. Go to, which one is it? Second window. No, go to window. Sorry, just window. Okay. So I'm at graph. Go to just window. You can tell the calculator, you know what? Move this down just a little bit. Okay. That means not the x-axis, the y-axis. Yeah? Y min means going down to infinity. Y max means the one going up. Yeah? Does that make sense? So the Y min right now, it only goes down to -10. So what if I wanted to make it go down to -15? Just write that in, -15. Okay, do that. Change it to -15. I think you'll be able to see it a little bit better. And then if you hit graph, you see how it kind of shifted it down a little bit? Made your window just a little bit bigger. Okay? Now, does your graph look like mine? All right. Let's go and find the vertex.
This one is -15. This one, you change the wrong one. Not the max, not the one that goes up, but the one that goes down. There you go.
Okay? All right. So guys, this vertex, is it a max or is it a min? Min. So let's go to second trace. Let's go get the minimum. Second trace, minimum. Now you gotta get Blinking Bob. Ooh, I don't even see Blinking Bob. But if you look, it says he's up at y equals 24. So he's up way up there somewhere. So I'm gonna hit the left arrow. There he is. Okay. I want him to find this guy right here. Yeah? So we're at the starting point. Go to the left. 1, 2, 3. Right, left arrow. 1, 2, 3. Hit enter. Go back. And then right arrow. 1, 2, 3. Hit enter. Right? It's a start left, start right. Hit enter again. What did you get? Yours says -4?
-4.
Good. If yours says -4, that's fine. If yours says -3.999, isn't that -4?
Yeah.
Yeah. So you should have -4, -8. That is your vertex. Which we said is the same as the minimum, so -4, -8. And then that means the max is none. Yes? So then guys, if I know the vertex, what's my axis of symmetry?
-4.
What is -4?
Axis of symmetry.
How do you write that? You can't just tell me -4.
-4 is -0.
What is -4? X. Please remember to put X, okay? It is an equation. Oh, what is the other thing that we can fill in here? What is always the case? Huh? Domain. What is the domain, Sabrina? Good. The negative infinity to positive infinity, okay? And you know what is actually pretty nice about this intercept form? It gives you the zeros. These guys, those are your zeros. Yeah? But, you know, since we put it into the calculator, let's take a look. You see how it looks like the x-intercepts are right at -2 and -6, right? Let's go and double check. Go to second graph, go to your table. At -6, what is your y? 0. That means -6 is a 0. What other number has a 0 at y? -2. So those are your two x-intercepts. Does that make sense? Okay. So my x-intercepts are at -6, 0 and -2, 0. Yeah? So you know what? I can go and graph that. Let's do it. -4. Okay, wait. -6, -2. Right? You know what? This is fine with me. You can do this. That's 3 points. The vertex and the 2 zeros. Right?
There's a whole bunch in there.
Huh?
There's a whole bunch in there.
Okay, I mean, just stick it and just work around it. So guys, can we talk about the range here? Remember, we look at the graph from the bottom to the top. Is this graph going down to -infinity? No, I don't have arrows going down. Where does this graph start? -8. And it goes up to where?
Infinity.
Good. So -8 has a closed circle, so that needs a bracket. And it goes all the way up to infinity. Yeah?
Mm-hmm.
Alright. So let's look at y-intercept. Alright, I know that this right arm is going to go up and up and up, and it's eventually going to cross through the y-axis. I just don't know where. So I can go to my calculator. I can go to graph, right? Now let's go to trace, 0, enter. You try. Trace, 0, enter. What did you get?
24.
Good. You should have 0, comma, 24. That is your y-intercept. Okay? Now let's do the increasing and decreasing, guys. I have an arrow on the left. Where's that going?
Negative infinity.
Arrow on the right. Where's that going?
Infinity.
I have to draw a vertical line through the vertex, which is
Negative.
-4, which is my axis of symmetry. What is this graph doing from negative infinity to -4?
Going down.
Good, decreasing. What's it doing from -4 to infinity?
Increasing.
Increasing. All right, there you go. You're increasing and you're decreasing. And remember, these are always parentheses, right? And guys, what are my two end behaviors doing? They're both going up to what? Infinity. Good job. Your left and your right one. They're both going up to infinity. Great. How are we doing?